in Sat S1, June 2014, question 6. Okay. A rubber seal is fitted to the bottom of a flood barrier. When no pressure is applied, the depth of the seal is 15 centimeters. When pressure is applied, the watertight seal is created between the flood barrier and the ground. Okay, it's a situation like that. You have 15 centimeters. Okay, and then there's more pressure, it gets smaller, and more pressure, it gets smaller, and more. It's like that. Okay, so state the value you would expect for A in the equation of the line of least squares regression. So this is what they're talking about, and think that is like, okay, that is the gradient and that is the intercept. Okay, and so imagine this line, what is going to look like. Okay, it's going to be like that, getting smaller. Okay, and at that point it's 15. So we think that the intercept is 15, so A is 15. So we'll write A equals 15. Okay. Okay, so A. Okay. Calculate the equation of the least squares regression line. Okay, that you can do it formally with the equations and the formula sheet, but you don't need to because they have given you raw data, so that means you can use the calculator. If they give you some nonsense like that, okay, things like that, yeah, you have to use the formula. Okay, but this time we don't. We're going to do this. Okay, so that we use the calculator. Put it in stats mode. Put it in stats mode. 2. Okay, choose 2 because that is the thing for least squares regression. 2, and put the data in because it's painful to watch. Okay, I've done it earlier. Now I'm cleared it and put shift and put stats mode. Okay, and choose, we're doing regression, so choose 5. Okay, and there it tells you A. Okay, so put that 1 for A. So 14.9060, sorry, 967. Okay, sorry, and find out B as well. Put it in stats mode, choose 5, and B is that. So B equals -2. Okay, so A is that and B is that. Okay, so this line, okay, is, okay, Y equals 14.9 minus 0.02903 because that's the gradient. Okay, and then you're going to put X. Okay, that's the line of least squares regression. Okay, it's an unusual question. It is a usual question, this. Okay, interpret in the context. So interpret in context your value for B. Okay, they're talking about what does B actually mean. Okay, it means every time you increase the pressure by 1, I don't know what the unit is, kilopascals. Okay, it's going to get smaller, 0.029. Okay, that's what it means. Okay, the next part is calculate an estimate of the depth of the seal when it's subject to 225 kp. Okay, this is possible because the range, this is the key word, is I can't remember it, interpolation. Okay, so you can interpolate because the range is 2 to 5 is within that range. That it's that somewhere there. So if you draw a graph, okay, like that, the graph is the information is up to 300. So you're quite valid in using that point. Okay, interpolation, because even though you don't have an answer for 225, it's quite logical that this works for 225. Okay, so use it to do see the pressure. So we'll use y equals 14.2 minus 0.02903 x. Okay, and x equals 2 to 5. Okay, so y equals 14.9 minus 0.02903 times 2 to 5. Okay, and then use the calculator. 14.9 minus 0.02903, okay, times 225, and it's going to be 8.36824. So to three significant figures, it's going to be 3.89. So when we have 225, okay, we expect the size of the rubber to be that much. Okay, so the last question, no, not the last question. Okay, give a statistical reason why your equation is unlikely to give a realistic estimate if the pressure is, if the thing is subjected to 400. Okay, notice this, it only goes up to 300. So if you draw a graph, okay, this is 300. Working in this range might not follow the pattern. Okay, you don't know, you only have data from nothing to 300. Okay, the data isn't valid. You don't know whether it's valid for 400. Okay, you have to I can't remember the word, extrapolate. Okay, and extrapolation is dangerous because you don't know how things react in the long run. Okay, so that is why you can't do it, because I think that it looks like it's going to be very small, and it's, even though a rubber can be compressed, it can't be compressed entirely. Okay, so the statistical reason is we are going to have to I'll think about how to write it. Okay. It's not valid because we are going to have to extrapolate. Okay, outside the data range. Okay, this is an area that we are unsure of. Okay, so the next part is to give a reason based on the context of this question as to why your estimation will not give a realistic depth of the steel if it was subjected to 252 pressure. Okay, this hints, okay, we have to use actual mass to prove it. So from before we have that. Okay, so y equals 14.9 minus 0.02903. Okay, x, that is the equation. Okay, and so then put you can usually put 14.9 minus 0.02903 and then times by 525. Okay, and I think it's going to be negative, so that is the key, and you can't have a negative value for volume. Okay, so 14.9 minus 0.02903 times 525. Okay, it's going to be 3.4. Okay, so y is going to be that much for 520. It's not possible to have a negative value. To have a negative value for volume. Okay, that's the question. Simple, really.